relies on systematic, recorded observation. Anecdotal evidence is just a personal, biased conversation. To find the objective truth, we follow the 5-step scientific plan. Memorize it with FDCAR, the blueprint for the scientific man. Formulate a theory and a testable hypothesis prediction. Design a study to test it out without a contradiction. Collect the data using observation, survey, or a test. Analyze the data and interpret how the results are expressed. Report the findings to the journal so the field can see. Reproducing and replicating research builds the validity. A theory is a system of ideas that explains what we see. A hypothesis is a specific prediction of what the result will be. Variables are the things we measure, control, or manipulate. But you need an operational definition to clearly state the rate. It defines exact procedures used to measure the variable at hand, so every single researcher can replicate and understand. Experiments versus observation. Observational, descriptive, and correlational studies just watch the trait. They cannot prove causation. They only show how things relate. But experiments manipulate the variables to see what takes effect. Experiments are the only way to prove the cause and effect direct. Participants are the people who are tested in the research frame. Let's break down the types of studies you need to know to pass. Experiments manipulate variables to see the cause in class. Questionnaires and surveys use self-reported data from the crowd. Naturalistic observation watches subjects in the wild out loud. Case studies focus deeply on a single person or a small extreme, gathering highly detailed data for a specific psychological theme. The independent variable is what the researchers manipulate. The dependent variable is what they measure to calculate the rate. Extraneous and confounding variables are the outside noise. They must be strictly controlled to maintain the scientific poise. If you test a drug on sleep, the drug is the IV you command. The hours slept is the DV, the measurement you understand. The experiments must be the special IV intervention. The control group gets nothing, acting as the baseline dimension. Random assignment puts participants in groups by pure random chance, ensuring both groups are equal before the variables advance. Between subjects uses 2 totally different groups to run the test. Within subjects uses the exact same group twice to see what's best. And if you test 2 or more IVs to see how they combine, that's an interaction showing how the variables entwine. Statistics describe the data and analyze the numeric score. Descriptive statistics organize and summarize what we saw before. Central tendency finds the center, mean, median, and mode. The mean is the average, the sum divided by the number code. The median is the exact middle score when lined up in a row. The mode is the most frequent number that the data sets show. Variability is how much the score is spread out from the average mark. Standard deviation measures that spread, keeping you out of the dark. But inferential statistics are what we use to interpret the final test, to see if results are real or just random chance at best. Statistical analysis minimizes the error in human reasoning and thought, proving the hypothesis is valid and the data wasn't falsely caught. Research is flawed when the data is biased or compromised. Sampling bias means the sample doesn't match the population size. The SIBO effect is when expectations make a fake treatment work. Social desirability is when subjects lie to look good like a jerk. Response set is answering all questions in one specific lazy way, like circling C on every test, regardless of what the questions say. Halo effect is when one positive trait makes you rate everything high, like judging someone as smart just because they caught your eye. Experimental bias is when the researcher's expectations skew the test. They accidentally influence participants to perform at their request. How do we fix experimenter bias and the placebo effect at once? Use the double-blind procedure so nobody acts like a dunce. Neither the participant nor the researcher knows who got the real pill, keeping the data totally objective in the scientific method still. Master these terms, know the variables, and lock the statistics down. That is how you pass Unit 2 and wear the medical crown.